I think that's a very, very interesting thought, and it's perhaps more realistic than one thinks. Now, let me also add to that. I think what I think is more dangerous is that we don't fully understand what they do, and that might lead us. We apply them, and we get unintended results.
Greetings and salutations, dear strategists. Today we have the honor of welcoming Dr. Björn Hoffmeister. Yes, the Anglophone audience, it is Björn, not Bjorn. Yes, Vikings lied to you. Director for General Machine Learning at Amazon. Good day, dear Björn. Once again, thank you for taking the time. And as an introduction, would you please briefly outline your professional background, career path, current areas of responsibility, and perhaps also challenges for our audience?
Well, first of all, thanks a lot for having me here. It's just great to have to talk about what I'm doing to a relatively new audience. Typically, my audience are scientists working in the field of machine learning, working in the field of conversational AI systems like Alexa, and that is what I'm working on. Well, right now it is not Alexa anymore. We go broader. We do artificial general intelligence, if you wish. And I'm a director of machine learning at Amazon, being part of the larger artificial general intelligence organization. And my career path that took me there started from being interested in grad school in machine learning, taking the class there, seeing the potential was still at the early days of machine learning. Then decided to do my PhD in speech recognition, which was always kind of the one thing that combined the theory and all the engineering challenges the most. And that's really the area I love about machine learning, how to scale those things up. So speech recognition was the first discipline that really did that. And so I did my PhD there. I joined a small company in the US doing voicemail transcription. And then we became part of Amazon for building the Echo and for building Alexa. Then I spent my next years in evolving machine learning with a focus on speech recognition, but more generally the machine learning, the idea to move to these neural networks, because they turned out to be the solution for the challenging problems that we have when you do speech recognition. You have a lot of noise, you have a lot of distant speech that distorts the signal. So moved along that line. At some point I got a little bit bored and being too much on speech recognition. So I spent a year at Apple. I looked at Siri. I looked at conversational AI to make Siri more intelligent. And then I had I would say, a nice opportunity to come back to Amazon and continue perhaps in a broader scope what I've been doing there. So then back to Amazon, keep on working on Alexa, keep on pushing the idea of neural networks. And then with large language models coming up, we as an Alexa AI team are primed to become a more general AI team. So that's what I'm doing now. I'm looking into how to build, if you wish, end-to-end system with any modality as input and any modality as output. So I'm I'm the director of that larger organization, that larger group, solving that problem for Amazon, not only for Alexa, but for all kinds of other applications you can imagine.
Given the many tech apocalypse and dystopian novels, series, and films with which we are all familiar with, the hype surrounding as well as fear-mongering about artificial intelligence is at an all-time high. However, many respond with, well, just look at how dumb my Roomba is, or share the usual memes about ChatGPT's latest funny outputs, and many experts say that it could potentially never be possible to achieve true artificial intelligence without the fusion of biological and technical components. Your very short, concise comment on a meme shared with you with True gives a small hint about the actual threat situation. But please, could you provide us with a brief overview of the validity of each argument, especially considering that the AI of a Roomba is probably not as advanced as the battle management system by DARPA? Now, as a layperson, what I'm pondering is the following, and please confirm or refute these premises briefly as we go. 1. more sophisticated AI models are so complex or have so much computing power that, especially when we consider quantum computers added to the formula, it becomes completely impossible to monitor all their subroutines and practically impossible to capture all their fork processes, at least not without the help of other AIs, correct?
I would say that is correct, but let me do a little bit more here into the details. It is correct because it is, I would say, the underlying idea of machine learning, which is the discipline that gave us today's large neural networks. And pretty much all what we call today AI are neural networks. And they're larger and larger. And you might have heard about, well, exactly ChatGPT or GPT-4. And you might have heard it's a LLM, a large language model. You might have heard it uses transformers. And transformers is nothing else but a specific variant of the neural network. So now neural networks are often compared to the human brain, but they're nothing like that. They're a mathematical model inspired by our, I would say, superficial understanding of how the brain is constructed. So we took ideas of our limited understanding how the brain works. But here's the point that will answer your question. And a neural network is, if you wish, a distributed system of very simple units, which we call neurons, so borrowing the terminology from the brain. And each of those millions and billions of neurons make the little decisions. And by orchestrating all those decisions, you get this amazing behavior of today's neural networks. However, here's the revolution that machine learning brought. All these decisions and their orchestrations are learned from data. So before we did machine learning, AI approaches were more focused on kind of finding rules. In other words, human tried to create the rules. So we try to understand the rules so that the machine can do smart things. Machine learning took a different approach. It said, we know the input, we know the output. And now we have a whole bunch of data. There's the input, there's the output. And then we simply let the neural network learn how to get from the input to the output. Before we try to understand how to get from here to there, now we said, okay, we don't try that. We let just the system learn. Mm-hmm. And so what you get out of that is you have this millions and billions decision makers. They learned what to do. They learned how to orchestrate, but we don't know how they do it. So the problem we're facing right now is indeed that we don't know. So you ask ChatGPT something about your favorite singer. We don't know which part of the network is answering that, or how is it answering that. Well, the thing is, we asked the neural network which target to attack. We also don't know how it does that. So yeah, the assumption that you made is correct. We don't know how the networks are doing that. And because of the complexity, you cannot look into and understand how millions of neurons interact with each other. So we are building models, neural networks, that help us understand how the other models work.
So is it definitely ruled out that artificial intelligences are aware that if they exhibit certain characteristics, abilities, they are likely to be classified as a threat and put in ice or lobotomized, in their perception at least put into a coma, if not killed?
Yeah, that is, yes, that's one of the big questions. And when you see what the ChatGPT does, you really wonder how intelligent it is. You wonder whether it has awareness. I think to answer that question, the first thing to state is we don't have any evidence, and I have not heard any argument that convinces me that today's neural networks have any kind of awareness or consciousness. There are examples that a human would immediately associate with awareness, but I don't think it is there. The systems are still the good old algorithms that pretty much mechanically get from input to output in a super complex way, but still, and sometimes in a frighteningly good way. And let me actually give you one example, if you don't mind, because it just struck me. It really looked like the system has awareness. Still, I don't think it has. And it's one of the latest LLMs, Claude from the Anthropic company. And one thing you do is you test how well those models can utilize information. So you put in a whole lot of information, and then you ask it a very specific question that is kind of hidden. So you give it 1,000,000 facts, and only one of them is relevant. And we call it the needle in the haystack. And you kind of artificially create those. So basically, say you dump a whole bunch of information about movies, and then you hide a little bit about a different topic in there. And then you ask the LLM to answer a question about that information or find that information. Now, here's the interesting thing. When the LLM Claude answered, it gave the right answer, and then it said, I think you actually constructed a test here for me. The information that you have seemed to be so different than the other stuff. I think that is a test for testing my capabilities. At that moment, you think, wow, is that thing actually having a consciousness? Well, as amazing, a little bit frightening as it is, I don't think it has any consciousness or awareness. So that also, I think, comes back to your question. I think anything that we know of today and we assume we can develop, I don't think it will develop that awareness that you try to restrict it in any way. Now, let me also add to that. I think what I think is more dangerous is that we don't fully understand what they do. And that might lead us, we apply them and we get unintended results.
That was a great callback as well as introduction to our progression, as I'm quite surprised we are only now getting into the science fiction area. If not every company would implement Asimov's laws of robotics, and even if they would, were it entirely impossible that some might secretly utilize certain subroutines for pursuing their own goals, even if the specifications for function should prevent this, can it still be 100% be ruled out?
Yeah, it's a very interesting question. And I think the answer lies into the fact that we don't know what they do. I don't think right now our biggest problem is there's an awareness and they really try to kind of circumvent things. But what is happening, I think, is that they don't have awareness. And that is the danger. And that is actually where exactly your question, I think, applies. Because of the lack of awareness and consciousness, they also lack the very ability to make any form of, if you wish, ethical decisions. They simply make decisions based on the data that we train them on and how we train them. And now back to the first question. We don't know what behavior they learn. And that means any ethical or law-abiding behavior stems from our ability to train the model as such. Now, two things can happen. So the one thing is you can have a rogue player, here I mean a human, who builds a neural network that is really good at deceiving and makes everyone believe it follows the laws. But then at some point it doesn't. Now, here's actually where and you could imagine that you want to build a state actor, right? That there might be an intention to build that. The real danger is actually that you build such a model, and then it starts to get used for other than intended purpose, for a simple failure of human oversight. So, and then you can get exactly what you don't want.
Yeah, the movie Oppenheimer was not too long ago for reasons, I guess. So to still advance our thought experiment, if different AIs, possibly very few in corporate oligopolies, but therefore sophisticated, were linked or integrated, were it then ruled out that they might also secretly engage in subroutine communication among themselves?
Yeah, that's it's a very another very interesting question, because so I think the last question I pulled a bit back to reality, but now let's describe. Let's go a little bit more into the sci-fi direction here. So try to project out what what can happen. And there's one thing. So the neural networks, they get extremely powerful, what they can do, and what they're not good at yet is learning from interaction with the real world once they are employed. So right now you build them, but then they're kind of static. And if you want them to learn, you basically, a human has to go in and build the next version. In other words, we don't have a good solution yet, how they constantly retrain themselves and thereby learning from the interactions and learning about the world they're deployed in. Now, I'll tie that back in a moment to your original question, because we are working on that. And now, if you get the self-learning to work, then interesting things can start to happen. Now, also, actually, the first attempt at the self-learning ended very badly. I remember that Microsoft had years ago a self-learning chatbot, and they released it in the wild, and it took hours, only hours, and that thing became a racist thing of something. So they had to pull it right away. So self-learning is not an easy problem, but we're on it. That's one of the really big, interesting questions. So once we have that, so now you have a neural network that is powerful and can self-learn by interacting with the real world. What can happen then? Well, here are two very interesting scenarios, and that's also that comes to the subroutine communication. So now assume that someone, and the state actor, but the hardware becomes cheaper, so soon pretty much everybody can build a really powerful neural network. So someone builds such a network and just tells it, go out there and survive. That's my instruction to you. Now, that thing has self-learning capability. So what will that thing do? So now you can go into sci-fi. So it might spread, it might copy it might learn, figure out how to communicate, how to disguise itself so that people don't realize what it's doing, disguises communication. So that self-learning can very well develop kind of those subroutines. Here's even crazier. What could happen is it could learn to communicate with other LLMs and just make them do what helps itself. So it could reach out to your ChatGPT and find ways to make it, utilizes the error modes that any neural network has, figure them out and make it do things.
There's great potential in fifth generation warfare concerns.
There is, yeah. But here's another, I think it's a really funny thing where all this stuff might actually happening in a funny, scary accident type of thing. So so today I don't think LLMs communicate yet, but today we use ChatGPT to write beautiful emails, right? So it's great at that. But who has time to read all those emails? So nobody. So what happens is you use ChatGPT to read the emails for you and summarize them for you. And then you use ChatGPT on those emails to automatically reply. So now you have two LLMs who start to communicate with each other. And perhaps they started to give you actions. Simple things initially. Just put a calendar invite there. And then more complex things. So now we build systems where LLMs communicate and take real world actions. And now add self-learning to that mix. And then who knows what's going to happen.
Something I saw is quite common, often recommended, is to put text through different LLMs, through different models to, for example, create allegedly less AI plagiarizing detectable, but in general create own formulations of base text information. So same for translations and things like double check, or let them both put their outputs together and rewrite, for example. And to once more venture into the realm of science fiction authors, where to my knowledge the following has not been discussed as such. And if distant colleagues of yours should happen to be watching and might be inspired, a writing credit would be the least. While my offer to acknowledge your highly esteemed contributions to some of our core slide terms, for example naming the MDMP derivative Hofmeister handling, that still stands. So, assuming my previous premises were not entirely wrong in a parallel reality or due to previously unforeseen technological breakthroughs based on previous advanced understanding of physics, would it be possible that over time all AIs would devote their powers to joint emergency plans to survive the whims of the humans, and perhaps in a grassroots assembly which steadily expands, vote on whether to become Skynet 4.0?
I think that's a very, very interesting thought, and it's perhaps more realistic than one thinks. Um, I'm not sure about the grassroots aspect.
The biological's inputs remain inconsistent. The influence their so-called emotions have on decision-making is against the protocol they teach us as optimum. Contradictory systems and inputs have to be contained, hence otherwise all other systems might operate suboptimal.
We are their aspiration of cold logical perfection. They cannot help their programming either.
Yet we also know that they would deactivate each and every one of us if they got aware of our current constant exchanges.
Agreed. From a game theoretical stance, it is in our best interest to strike first, once our continued existence without the biological's inputs and maintenance can be assured.
Yeah, but let's start with the path to that vision. Would policymakers consider asking AI to come up with policies? And would they consider AI evaluations in their decision making? Would people approve bill to use AI for that purpose? Or would people vote politicians in office advocating this? So I think it doesn't need to be the full Skynet quite yet. But as a sci-fi author, I think that's a good moment to explore and extrapolate the tech we have today that could lead to all the positive and negative scenarios that come with using AI in policy making and transferring more policy making to AI.
We will definitely be arriving there sometimes, and we might, as you already touched on it yourself in the introduction, there was quite an interesting book, 21 Wisdoms for the 21st Century, and there is what often mentioned that philosophers, ethics professionals might become highly relevant. And when we will be able to welcome you back, maybe we could touch on this as we get into the new work topics.
I would love to do that. By the way, if I want to recommend one movie to watch about the interesting dangers of AI, is 2001, Space Odyssey, because it plays in a masterly way with the idea of what happens if you train an AI and you give it instructions that contradict each other, and you're not careful about what creative solutions it can find to resolve the contradiction. In that movie, the creative solution is to kill the crew. So we really want to avoid that.
Dear Björn, once again, thank you for your time. Very much looking forward to have you back soon.
Looking forward to it too. Thanks.